Hello, I'm John McGrath. I'm a startup solutions architect at AWS. And today we're going to be doing a recap of the best of reInvent from the most recent reInvent. This is specifically geared towards startups. So we're not going to be covering the panoply of somewhat overwhelming number of services and features that were launched, but a subset that are specifically of interest to startups. At the end of the event, I'll post a URL where you can see everything. So the stuff we're going to cover, we've grouped into 4 different categories. The first is machine learning and artificial intelligence. And specifically, we're going to take a look at Amazon Ground Truth, which is for labeling model data. Amazon Textract, which is for extracting text from documents. Amazon Personalize for creating recommendation services. And SageMaker RL, which is an extension to our SageMaker platform, if you will, for doing reinforcement learning. And SageMaker Neo, which is to optimize the deployment of machine learned models. We're also going to look at databases. We have a growing family of databases, so you can use the correct database for specific workloads. And we're going to look at time stream, some very powerful new features for Dynamodb, and also QLDB, or the Amazon Quantum Ledger database, which will serve as a good lead-in to blockchain announcements. We'll talk about the blockchain aspect of QLDB, and also Amazon Managed Blockchain. And we will conclude with some serverless announcements. One much anticipated one by me and many others is called Lambda Runtime, which gives you the possibility of running code in any runtime as a serverless Lambda function. And related to that, we'll talk about layers, Lambda Layers, which is a way to package dependencies. And then some kind of more nitty-gritty serverless features of existing products that are really powerful. And a lot of people are very excited about. This includes Lambda as a target for an API gateway, and WebSocket support of ALBs, I should say, and WebSocket support for API gateways. So first, let's dig into machine learning. So the overarching mission of the Amazon machine learning products is to get machine learning into the hands of developers and data scientists. Historically, it's a deeply specialized and difficult field, very powerful, but not available to a wider technical audience. And we are solving that problem. This is the pre-invent machine learning and artificial intelligence service stack. And I apologize that there's a lot on this slide. It's a little hard to read, but that's because we have a broad array of offerings. Let's work from the bottom up and talk about the stack that lets you do machine learning tasks on AWS. At the lowest level, we offer frameworks prepackaged in Amazon Machine Images, or AMIs, that offer things like TensorFlow, MXNet, PyTorch, a pretty broad assortment, a quite broad assortment of machine learning frameworks, and instance types that are optimized to run them on. So that includes the P3 EC2 instances with onboard GPU acceleration, VT100s, very powerful. C5 instances that are high memory instances suitable for training certain types of models. FPGA instances, and Greengrass, which is a service to run Lambdas and other code on the edge on devices like Raspberry Pis. So now let's work our way. Oh, and then SageMaker, sorry, I almost skipped to the other layers, is a managed service to run machine learning workloads. And that abstracts away the actual creation of nodes and management of clusters so that practitioners can focus on the machine learning specific tasks they're trying to do. And that facilitates the building of models and training of them, and the deployment of them with the underlying heavy lifting done by AWS. And then on top of SageMaker is a series of AI services where the machine learning has actually been done by AWS and then offered as a service to developers. So there's various families of services. Vision-related services include Amazon Recognition for image recognition and now video recognition. Speech-related services for text-to-speech and speech-to-text. Language-related services that translate in an increasingly broad variety of languages. Amazon Comprehend, it's a natural language processing service in essence. And Lex for the building of chatbots. So now let's work our way back up the stack and talk about the newly announced this reInvent services related to this. And some of these I'll go into a little bit of depth, and others we'll glance over because we're going to go into depth in a moment in subsequent slides. So Amazon Elastic Inference offers the ability to allow fractional GPUs or to attach fractional portions of a GPU to any EC2 instance. This is a tremendous cost saver because if you need GPU to run models after they've been built, you typically need a lot less of it than you do to build the models. So if you're using something like a P3 instance to run models, you probably are over-provisioning. By attaching Elastic Inference hardware or portions of it to something like to smaller instances, you can save a lot of money. We've also offered new instance types to add more flexibility and power. So the P3 is joined by the P3DN, which has up to 100 gigabit per second networking, and onboard fast storage. It's NVMe storage. Working our way back up. And again, I apologize for that. On the screen, it's not super visible. It's in red, but that says part of a new SageMaker offering is SageMaker Ground Truth, which is a service for labeling data for modeling. And we'll get into that more in a moment. There is now also a marketplace, part of the larger AWS marketplace for AI and ML services where you can purchase pre-built services and sell the ones you've created. We'll talk more about that in a moment. We also now offer, as part of SageMaker RL, extending the kinds of machine learning you can do from supervised and unsupervised machine learning to include reinforcement learning, which is a different category, and we'll talk about that in a bit to solve different kinds of problems. SageMaker Neo, which is powerful optimization of models once they've been built so they can be optimized and deployed for different platforms and different hardware. Working our way up one more level. Joining the vision, speech, language, and chat services, we now have a recommendation service called Personalize. Amazon has historically spent a lot of time and resources building powerful recommendation engines for Amazon.com. We've taken a lot of our learnings from there in technology and offered it to AWS customers so you can input your own data and build your own recommendation engines for your products. We'll look at that in a subsequent slide. Amazon Forecasting, in a similar manner, lets you import historical data and use it to create models to forecast the future. And Amazon Textract sits somewhere between speech and vision. And it is more than just an OCR service. It's a service to extract in a powerful manner text from scanned documents, so from images. And not just, OCR can be a blunt instrument. Textract is a lot more sophisticated. We'll get into that. So SageMaker, the pre-invent version of SageMaker. You can build models. You can use notebooks to begin that process. You can use a slew of high-performance algorithms, again, TensorFlow, MXNet, and friends. Train and tune them, and then deploy them. Joining this now, the stuff I mentioned earlier. One is the ability and improved ability to label data. So traditionally, when you look at unlabeled data, you see an image here, you might have a lot of trouble determining the white blob on the right from the white blob on the left. And if you're building models for autonomous driving, that could be a very big problem. So you label your data. You look for polygons, you find shapes in it, and typically, manually, you'll have a human say, this white square over here is a car, and this one over here is in a mobile road. One will move and one will not. And then, given enough of that type of data, machine learning does what it does. Very labor intensive. I've heard people say the dirty little secret of machine learning is it's actually it's very human powered. SageMaker Ground Truth addresses that problem in two ways. The first is that it will automatically label a significant portion of your data. So you're getting a little sort of like, maybe we're approaching the singularity here where you have machine learning facilitating machine learning. There's some portion of your data where that will not be possible with a high enough confidence level. So built into Ground Truth is our features to facilitate human labeling. Those can be workflow procedures for your own labelers. It also is integrated with Amazon Mechanical Turk, which has a workforce of 500,000 people, very commonly used to do labeling of models or data for models. In addition to that, you can provide your own labelers using the Ground Truth toolset. And we have integrations with third-party labeling services of particular use if you have very domain-specific labels, say in the medical field or where you need people with domain-specific knowledge. So how does it work? You take the raw data, sensor data from cars, textual data, whatever's appropriate for your model. The models are trained from human label data for our models to automatically tag your models. Where possible, that is done. It's fed back into the model. Where there is ambiguous data, it's not sufficiently confident to apply automatic labels. It goes through the process I outlined a moment ago and is sent to human labelers of your choice, utilizing workflow tools that makes it faster and cheaper for them to do what they do. And the result of which is an accurately labeled model much more quickly and at lower cost than is typically possible. So let's move on to SageMaker RL, reinforcement learning. And just a quick, very high-level overview of categories of machine learning. This is obviously a massive topic, but two common approaches are supervised learning, which is done with labeled data, and unsupervised learning, which is done with high volumes of data, not necessarily labeled. And supervised learning is going to build more subtle models, if you will. Unsupervised learning is frequently done for models that produce a more binary output. They are capable of solving difficult problems, but maybe you might say with less subtlety. But they're both done with large data sets. Add to that reinforcement learning. Reinforcement learning is a different category of algorithm, solving a different category of problems, where the nature of the problem perhaps doesn't permit high volumes of data to build models. You can think of something like in thermodynamics, some financial calculations. It's just not possible to have a data set that you can label or that you can run unsupervised learning from. The approach taken instead is to build a simulation of the environment, say an HVAC system. Put a computer agent into the simulation. That agent acts. It is graded on the actions it takes. Very commonly, it'll be rewarded or punished is the term of art that's numerically. And you repeat that enough, and you'll build a model capable of taking accurate actions. For instance, make its way through a maze using reinforcement learning. So SageMaker RL, like the other SageMaker algorithms, it's fully managed. You're not in the business of handling EC2 instances directly. It supports appropriate algorithms, and there are variants of MXNet and TensorFlow and other algorithms that are reinforcement learning specific. And it has support for building the simulations that I mentioned. There are libraries to do that as well, Simulink, MATLAB, a number of others. So you can do this whole new category of machine learning on the SageMaker platform. Once you've built a model with RL or the existing SageMaker tools, you need to run it. You have been able to do a one-click deploy of a model to do inference or the actual using the model to solve a problem. With Neo, you can specify a target platform, create a binary to be deployed to it, and typically you're going to get, using the Neo binaries, a 2x improvement in speed and a 10x improvement or reduction in memory footprint for the model. This allows it to be deployed to smaller devices. It allows you to push inference out to the edge and therefore apply ML in a greater variety of circumstances at lower cost. So it can be deployed to NVIDIA, Intel, Xilinx, Qualcomm hardware. It really advances where you're able to deploy machine learning. How does Neo work? As with all the SageMaker tools, you're going to be building a model with the framework of your choice. Just as a side note, you can import your own algorithms into SageMaker. You're not limited necessarily by the set that are offered out of the box. You train and tune it. And this is where you get into the Neo-specific stuff. You choose your hardware platform so that it can be compiled in an optimized manner, which offers these speed and memory footprint advantages. And then deploy it out into the cloud or at the edge. So a moment ago, we mentioned the AWS marketplace for machine learning. And like any marketplace, it has two sides, producers and consumers. If you are solving a problem that is perhaps someone else has solved and offered as a product, you can search the marketplace and perhaps save yourself a lot of development time by something that's battle tested. Or if you're producing AI ML products, conversely, you can package them, place them into the marketplace, gain a much broader distribution channel than you might have been able to otherwise, and have it automatically validated on SageMaker and provide a self-service listing. So if you're not a data scientist or a machine learning expert, but you want to take advantage of the power offered by it, and you have a problem that could be addressed with machine learning models or artificial intelligence, you can use the higher level suite of AI and ML products. And we're going to take a look at personalization. It's a difficult problem. It needs to be done in real time. If someone visits a specific product page or is taking a certain action on an app or a site, you need to provide the recommendation then and there. It's not very much use, typically. If you don't, if you have not yet built a large corpus of data, it's difficult to train your models. So this is referred to as one type of a cold start problem. You want to offer recommendations on a new service. It's hard without a corpus. And scaling is difficult. If you have a large number of products and or a large number of customers, you need a platform that'll let you manage that. Amazon Personalize is that platform. Because it's based on decades of work optimizing recommendations, it delivers high-quality recommendations in real time, managed. It can be addressed through the AWS console or via APIs or SDKs. And it works with almost any kind of content. So you're uploading your own catalog, whatever it is, and Personalize will be able to turn it into recommendations. How it works is that you take the data that you're inputting, people signing up for a site for whom you want to recommend some subsequent activity, products, et cetera. Your inventory of those, it could be articles. A lot of media companies have recommendation engines you might also enjoy. And then it takes demographic data, because people in different demographic groups might have different preferences, and you can factor that in to your personalized models. And then it'll run it through a pipeline. Load it, inspect it, identify the features in the machine learning sense of that term, choose the correct algorithm with which to process it, select hyperparameters or the fixed variables rather than the ones that will be manipulated by the model, train those models and optimize them, and deploy them, and cache them. So part of the scaling and performance benefits you're going to see are the caching features built into Personalize. So let's take a look at another high-level AI service, Forecast. So you might be able to forecast within a range using statistical methods or a variety of tools. If that's a broad range and it goes above and below some number, it's not going to be super helpful. You might you might lose a ton of money, you might make a ton of money. Like, how do you plan with a forecast like that? By making I have a soundtrack now. Cool. By making forecasts more accurate, I didn't choose, I think this is Toto. You can make more actionable business decisions. We think we're going to lose money. Let's change things. We think we're going to make money. Let's double down on it. Like other Amazon services, you're going to be, before we get into how it works, let's talk about the benefits you're going to get. You're going to improve the accuracy utilizing our trained models that have benefited from years of our work and tremendous volumes of data. So you're going to see up to double the accuracy at greatly reduced cost. It will work with any time series data. So in order to provide future predictions, it needs a certain amount of time sequence data from the past. And like these other services, it's easy to use both through the console and through the API. So when constructing this, you also have to build an API. There's a lot of kind of grunt work associated with making services like this that you might build on your own available, and that's all taken care of. So how it works is you're going to be ingesting historical data. Also related data. You can't do forecasts without some domain knowledge frequently. Amazon.com, huge traffic around the holidays. Other shopping sites similarly. I used to work at the New York Times. Everybody knows the deadest news day is Christmas, the exact opposite. So you put those kinds of patterns in, calendars, et cetera, along with your time series data. Forecast will build models, inspect the data, look for key attributes with respect to everything you've put in, then run it in a way that's actionable for your business. It'll build visualizations, dashboarding, let you output it so you can use it in other BI tools, CSV and other formats, and make it retrievable via API. So if you want to integrate it programmatically with other tools or a workflow, it facilitates that as well. So let's take a look at Textract and how it differs from traditional OCR. Bag of letters is actually a technical term in the sort of OCR community, and it's what most OCR software does. It often effectively will say, this picture of these squiggly shapes is actually the word and it'll scan line by line and pluck out all the words and letters and then dump them in a database. And unless everything you're scanning is like old-fashioned typewriter text that just goes left to right in a single line, it might be difficult to make sense of it. If you have columnar data, if you have tables and figures, if you have forms, it's going to be hard to handle. Textract is able to handle those. It's able to differentiate different types of content in different places. So it can be understood and used more effectively. It's fast and accurate because it's running on the substrate of the AWS's significant infrastructure. Because it's able to understand all these structures, it's going to eliminate a lot of manual post-processing that's typically done with OCR. And it's going to lower your document processing cost as a result. And there are certain workloads where people are analyzing vast volumes of documents. Think like legal discovery processes where the government decides to give you a container truck of boxes of paper as opposed to anything else. This is going to make, or potentially could make, the analysis of that a lot faster and a lot cheaper. So let's talk databases. For a long time, that term was synonymous with a relational database. Relational databases are very powerful, and like a lot of developers, I cut my teeth on them, and to this day think in a relational mode when I'm trying to solve a problem technically. But that is only one tool, and it's not always the correct tool. So an analogy is that, oh, we need a truck. Well, no one just says, well, get the truck. We're moving 10 tons of earth or some avocados or a piece of furniture. You're going to get a different truck or container. Likewise, if you have time series data, if you have unstructured data, if you operate at different scales, you're going to ideally choose a data store appropriate for the problem. So pre-invent, we had certain categories of databases. We've been increasing the nature of our offerings for different workloads. We have a suite of products under the Amazon Relational Database Service family that offer managed hosted traditional databases with the engines of your choice: MySQL, Postgres, SQL Server, Oracle, others. We have a NoSQL database, key value, document-oriented. Dynamodb is the flagship offering there. It powers most of Amazon.com. It's battle-tested and scales incredibly. For some reason, we're not skipping. There we go. I had those backwards. In-memory databases. Elasticache is our hosted offering for Redis and Memcache. It's actually key value as well, but it's also in-memory for very fast caching, typically. And Neptune, which is a graph database for workloads that are graph-like. So why do we need to add to this? Building products with time series database using the existing tool set is difficult. You have a sort of a round peg, square hole problem. Relational databases are slow, and you end up having to build a lot of the time series features in code on top of it. It's inefficient to process. Rigid schemas are not ideal for streaming data that is often how you ingest time series data. It's harder to scale. Because of that, you're often running clusters that are difficult to maintain and have highly available. And you have limited lifecycle management. A lot of streaming real-time data, you're talking huge volumes. Relational databases at scale, it can be a challenge to cycle data out while you're also putting data in. We have launched Amazon TimeStream as a managed time series database to address those challenges. This is a crazy stat, but I've seen it. TimeStream can be 1,000x faster than an equivalent product built well on top of a relational database because it's highly optimized for these workloads. And subsequently, it's often 10x less expensive. It's optimized for very high volumes of data and high throughput. I've spoken with customers who are putting devices in every outlet in high-rise buildings at 60 hertz. Small bits of data, but tons of it, needing to be sequenced. Very challenging problem to solve without purpose-built tools. The analysis of that kind of data, likewise, is challenging. And managing the infrastructure on which it runs is challenging. TimeStream is serverless, like many of our more recent offerings, meaning you're not dealing with the underlying servers. There are servers there. You just can't see them because we manage them for you. How does it work? You're sending data in frequently from devices, industrial equipment, sensors, things like clickstream data, high-volume data. TimeStream stores it in the appropriate format, makes it queryable. The BI tools on top of it do allow a SQL-like querying feature, which is great because you can utilize your existing understanding of how to run queries, and SQL is kind of the lingua franca of query languages. And once you have that, you can use it to build machine-learned models. So if you'll remember a moment ago when we were talking about forecast, it required as an input. If it's a quick question, I can take it, but otherwise, we will wait till the end. Internally, I'm not sure. If you grab me afterwards, we can talk about the kind of format you can get out of it. So it's suitable for making predictions. You can use it in something like forecast, or you can export it for your own purposes. So let's talk about database capacity planning and significant new features for Dynamodb in particular. If you want to make sure you can handle expected capacity, you might be over-provisioning what you need, in which case you're paying more than you ideally would like to be. If you optimize for cost savings over comfort of knowing you can handle a certain load, and the load exceeds what you've provisioned, you're going to degrade the user experience, possibly not be able to handle requests. Imagine that you're running an online store and it's Christmas and you've done this. It can be a significant cost to your business. At reInvent, we launched Dynamodb on demand. So rather than provisioning capacity, you can choose to have it automatically provisioned for you. So as Dynamodb detects load on the system, provides capacity, as it detects that load has declined, it reduces it, therefore reducing your costs. So that curve of demand is matched by an equivalent curve of capacity. So it eliminates that trade-off of high availability and essentially confidence with cost. And it ramps up and down rapidly as you need it to do so. Joining that with Dynamodb is a new set of transactional APIs. So one use case that NoSQL has often not been suitable for are transactions that require ACID compliance, which is to say they're guaranteed to have occurred. If there's a problem, they're guaranteed to be rolled back to a known good state. If you're a bank, you can't have eventually concurrent states where one person looking at a balance sees one number and then 3 seconds later they see another number. That's not, you simply can't have that. Therefore, Dynamodb wouldn't have been a good choice for workloads like that up until this point. So order processing, where you need to know, did this clear, did it not? If you use transactional APIs, that is now possible. Coordinating multiplayer games, everybody needs to see the same state at the same time. It's well suited for distributed systems as well. So this dramatically expands the number of use cases for Dynamodb. So here's the family of database services we saw before, but this is post-reInvent. We offer RDS, key value and document models. And here's a little bonus. Since reInvent, we launched something called Amazon Document DB, which is a MongoDB compatible document store. So this has been a super requested feature with my customers, and I think across AWS. is, why don't you have hosted MongoDB? Well, now if you're running MongoDB, you can use DocumentDB, and it's API compatible with specific versions of MongoDB. It's drop-in replacement for those. That's, a lot of people are very excited about that. Elasticache, Redis, and Memcache. Neptune, their hosted graph database. And those are now joined by TimeStream for time series data. And something that's sort of sits between two paradigms, a ledger database that we've just launched at reInvent this year called the Quantum Ledger Database. And it uses technology from the blockchain world, crypto world, to allow you to have a blockchain-based database. And we'll get into that in a moment. And you can call that a centralized ledger because it's hosted on AWS. You have a central repository, unlike, say, Bitcoin, which is distributed. And the use cases for this are absolutely verifiable transactions. So in the financial world, in the healthcare world, you really want to know, like, does this patient have cancer or not? And you want to know their full health history. A LedgerDB will make that possible in a cryptographically verifiable way. Likewise, financial transactions, contractual, clearing contracts. You don't want that to be fudgeable. You can build that in relational databases with something like an audit table, but it's less secure. I mean, if you have root access to a relational database, you can make the audit trail say whatever you want. That's not possible with a LedgerDB. It's supply chain management, HR and payroll, sensitive data of this nature. I've seen customers in the cannabis industry very excited about ledger databases because California's recent laws in that area require what they call seed-to-sale tracking. You need to maintain a record of the supply chain from the moment it's planted until the moment the end user consumes it. It crosses over into the medical world, and there's a lot of regulation around it, and ledger databases make that much more feasible. The challenge of building them is that it's difficult to do things like verification on top of a traditional database. You can use existing blockchain solutions, but those are more challenging to build, and you're going to be adding features they come with features that you don't necessarily need for this use case. They're harder to maintain, and they're slower. This is often because if you think of the Bitcoin world, you need to have a quorum of nodes basically voting whether should we count this transaction as having occurred in the chain. And if you have a centralized ledger, that's not necessary, and performance is subsequently improved. So how does QLDB work, Quantum Ledger Database? You're putting transactions into it from the type of use cases we just went through. It is strictly additive. There is no concept of an update of an item or a delete. You append the new state of an item to the chain. It's immutable, i.e. unchangeable. It's cryptographically verifiable. So after the fact, you can run an algorithm and say, did this in fact happen? And know with mathematical certainty whether it did or not. Because it's append-only, you can see the full history. So in the healthcare world, it's nice to know, like, what is this person's current health state? It's often vital to also know what is their health state for the last 10 years. And with something like a ledger database, facilitates that. And like all managed services, I should say, we offer the layers on top of this to make it easily accessible. By updatable, let's read appendable, just to avoid some confusion there. And we just went through some of the use cases. Supply chains, financial transactions, mortgages. Has something been approved or not? There are others. Related to a cryptographically verifiable database is the concept of a blockchain network. And that expands the set of problems that can be solved with this technology. What are the challenges with a blockchain network? They're difficult to set up and manage. They're hard to scale when you're managing your own clusters. Difficult and complicated. And expensive. Recently introduced product to address this service is Amazon Managed Blockchain. It will create a network for you, facilitate the addition of new members to it, and the addition of nodes, and help you deploy applications onto it. You can deploy Ethereum or Hyperledger nodes. And those can be private networks. You can also make them available as part of public networks. So now let's talk serverless, which has been, I think, like it's a paradigm many companies and developers are moving towards, which extends the amount of your infrastructure that you don't have to even think about. It's managed by your cloud provider, Amazon. The core serverless product from Amazon has been Lambda, which lets you upload code or functions into the cloud and run it as an independent unit without thinking about either the container or the instance it might be running on. And from launch, that was limited to runtimes that were officially supported by Lambda. So Node, Python, PHP, Java, .NET. Golang was added last year. And if you weren't running those, sometimes you could sort of hack some in, but it was difficult and not officially supported. So before I get into the meat here, which is Lambda Runtime and Layers, we added Ruby, much to my delight as a Rubyist, as an officially supported runtime. We also made it much easier for you to add the runtime of your choice. So if you prefer to run Erlang, it's either esoteric stuff or popular stuff that we just don't happen to support, you can now define that yourself and run it. Related to that, and actually what that's built on top of, is something called Lambda Layers. This is a package management service, if you will, that lets you take libraries and create a layer and make it available to all of your Lambda functions. So creating dependency chains, reusing code, architecting code cleanly is all much easier utilizing Lambda Layers. And in fact, Lambda runtimes, it is a layer. So these work together. You can deploy up to 5 layers per Lambda. If one of them is a runtime, that counts as one of them. Your deployment of your Lambdas will be much smaller if you've taken shared code and moved it into a layer, although it's worth noting that the total size of the deployment that's counted towards like the max of a Lambda includes the layers, all uncompressed. So it's similar to the current Lambdas in that sense. And they can be shared across accounts, across developers. So it really facilitates code sharing and good architectural choices. Some other Lambda-related features that are a little bit closer to the application developer than not fully managed services per se, but have been requested. This has been requested a million times. And it's, I think, going to make heterogeneous architectures much more feasible, is that the application load balancer, which is the current family of load balancers, has always allowed you to put different instances or different containers behind it. You can now also put Lambdas behind it. So it makes it much easier to do things like migrate to a microservice architecture. If you have legacy systems and they're running fine and ain't broke, don't fix it is a wonderful sort of guideline for application development. You can put those apps behind some endpoints, and new development can occur in serverless.
So this means you could specify, say, a directory and what it maps to from a single ALB. Is that
Not a directory per se. I think just an endpoint, and which would be hitting a Lambda. So not exactly a directory.
But from the ALB perspective, you can route some traffic to Lambda and others to EC2.
The question was, can you route some traffic through an ALB to a Lambda and some to EC2? And absolutely. And if we want, we're going to hold off on questions for a few reasons here, but absolutely grab me afterwards and we can go a little deeper into it. But that is the purpose of the application load balancer, these new features, is to let you have different technologies behind different endpoints. And the load balancer acts as a sort of interface that is shared across them. Similarly, the Amazon API Gateway, which lets you define APIs. It can use Swagger, or it can generate Swagger if you're familiar with that as an API definition format. Now supports WebSockets. This is another incredibly frequently requested feature. So if you're building real-time applications, chat applications, a lot of gaming applications, and you need WebSocket support, that can now be delegated to the API Gateway. And it both simplifies development and enables a lot of cleaner architectures utilizing API Gateway is a great service. You no longer have to manage things like your own WebSocket servers. So that ends the stuff that I started off this deck talking about, or saying we were going to mention, but I couldn't help last night squeezing in a mention of AWS Ground Station, which might not sound like it's startup oriented. What it is a fully managed service for satellite communications, where instead of renting or building a ground station, which, as you can imagine, is incredibly expensive, you can buy fractional time on AWS managed or leased ground stations. I have talked to a surprising number of startups that are deploying what are called CubeSats. Small satellites, they come in a variety of sizes, the smallest of which is called a nanosat. And you can buy remnant space on rockets, stuff them full of nanosats, and it's really quite cheap to get into space, certainly compared to historically, but even just compared to other types of startups. One of the sticking points with that is, like, how do you get your data off it in a cost-effective manner? Now you can buy AWS Ground Station like it's like a fancy S3 bucket, S3 buckets in space. It'll download data and put it where you want it to go, which often is an S3 bucket, or into streaming services like Kinesis, or Recognition, because a lot of the data that comes down from satellites is image-based. And then pipe it through the whole ecosystem of AWS services as suits your application. And your cost of handling, running a ground station plummets. So thank you. This is a small subset of everything that was announced at reInvent. There's a bunch of other stuff that might well be suitable to startups. It depends what you're doing. So I encourage you to take a look at the full list. Set aside an afternoon, practically, it's huge. There's some very cool other stuff. Some of the more enterprisey stuff might actually be suitable for startups that are selling to the enterprise. So take a look. And we have a few minutes before the next talk, so we'll have a break prior to that. And as I said, I'm going to be hanging out all morning, so I would love it if anyone wants to come up and grab me, and we can talk about this or anything else AWS related. Thanks for your time and attention. We'll have our next speaker up at, I believe, 11:15.